second speaker is Subhash Paluru, and he is Senior Vice President and Regional Manager of Western Area Power Administration. And his story is going to be about protecting critical infrastructure with software-defined network technology. And I have to say, when I first heard about this technology being deployed in electric infrastructure, I literally fell out of my chair, because my forecast was I'd seen the stuff and said, well, this is great. When is it going to, people said, when is it going to come into the industrial space? And I said, well, not while I'm alive. But clearly that was a very bad forecast, and Subhash will tell us a little bit about what they're doing with SDN to protect the infrastructure at Western Area Power Admin. So please welcome Subhash.
Thank you, Harry. All right. So good afternoon, everyone. I just found out that there is one thing common between Penn State and the United States government. We also have rare specimens. I'm just kidding. Thank you, Harry. I am Subhash Paluru, and we are the United States, part of the United States government, Department of Energy. We are a power marketing agency. So that means all the power that comes out of the hydroelectric dams, we are authorized by Congress to sell it or market it. Let's see if this works. Perfect. So I am a Doug. So I'm a dumb old utility guy. Been with WAPA for 20 years. Before that, I did my postdoctoral in physics. So I'm a little uneducated. So what does WAPA do? Western Mississippi, there are 18 states, and out of the 18 states, 3 states are Bonneville Power Administration. That is Washington, Oregon, and Idaho. And the rest of the states are WAPA. We have about 57 facilities, generation facilities. So this is how WAPA is. So I wrote it down because I was texting my boss, who is the administrator of WAPA, reports directly to the Secretary of Energy, Secretary Perry. And he basically, when he shows this map, he always says it's the size of Paris to Moscow, Athens to Oslo, and with all the politics in between. So I thought it was very funny, and he gets a lot of laughs when he says that. So I thought maybe I'll steal that today from him, because I am representing WAPA today. So there are 4 power marketing agencies in the Department of Energy, and this is how we are: BPA, WAPA, SWAPA, and SEPA. So SEPA is the Southeastern Power Agency, by the way, is the only agency that does not have any transmission assets. So basically what they have is the authority to sell the power off of the dams that are run by Department of Interior or the Corps engineers, and they just market through other transmission utilities. But BPA and WAPA, we have tremendous transmission lines. As a matter of fact, the Western United States, if you know how the utilities operate, we work like a big donut, anti-clockwise donut. It's like a huge transmission line that goes around. So, and WAPA manages almost a third of that. We manage all those phase shifters out there, which are very, very important for loop flows and all that. Extremely important. I see Bill Lawrence there nodding, because I can see one utility guy actually have a big smile, so I'm very happy. So I'm trying to build up the case here, so build up why this is so critical for the nation. And WAPA has all the way from 500 kV transmission system all the way down to 100 kV. There are only certain instances that we operate under 100 kV, and those are the times when the Congress authorizes or mandates us to do something. So I'm a special case in California because I operate in California and Nevada. There are 2 congressionally authorized projects. One is called the Central Valley Project, and the other one is called the Washoe Project. The Central Valley Project is where you get all your food from. It's the food basket of America. So my job every day, I'm very proud of it, is to to get the power out there to the farmers and the irrigators and pump the water so my good friends in Southern California can get their water. So believe it or not, I have 400 megawatts of pumping loads. So those pumps look like big dam generators, huge. They are variable, so when they run, they also generate. Good news. So this is how the power plants in WAPA is. I mean, we have over 17,000 miles of transmission, huge. Over 300 substations. Now you have to put a perspective in here because this is all I'm talking transmission. This is not distribution. So when folks say we have several thousand substations, they're very small. I mean, I can give you an example of one substation that I operate in the Bay Area, which is very critical for the Bay Area. It's about a few square miles. So it's huge. So it takes my guard 45 minutes to make a full round in his vehicle. So that's how big these are. And so comes a lot of responsibility because we have so many transformers and breaker schemes and, oh my God, you name it. I mean, it looks like a big maze. So we need to protect those. It's very, very important. I still remember, I'm pretty sure a lot of my utility friends here remember, not long ago, about 10 years ago, you could just drive into a substation without even, I mean, the doors, the gates are always unlocked. And now we have two-factor authentications. And my crews, they hate it, because they're coming in their big rigs, and now they have to get down and go and then do that. And now you have a timer on those gates. 30 seconds they close. So they have to run back. So they have to practice that. It all goes back to that security. So I'm going to stop a little bit, and I'm going to crack a joke here. I'm giving away. So does anybody know which is the biggest public enemy for the utilities is? The biggest public enemy? Bingo. So squirrels, because the data suggests that we have many outages because of those. Although Bill is right, because in Northern California, we get migratory birds, and I get millions and millions of those sterlings, and I have a big problem with them. California is the only place that I'm aware of where we wash down our substations at least half a dozen times a year, completely wash it down. And we take away almost 3 or 4 truckloads of bird poop every year. Seriously, not kidding. So, well, WAPA has $1.4 billion in revenues every year, which is great news because they all go back into the treasury. So we are one of the rare government organizations that make money for you. And all those green generators over there, they all are the ones that I control, in the sense that the Bureau of Interior, Department of Interior Bureau of Reclamation, my peer, David Morello, is the one who runs the water operations, and I run the power operations. So that's the demarcation. So we, out of our revenues that we have, we give that money to them to manage physical cyber security and the O&M, the operations and maintenance of those big generators. So here's the problem statement for WAPA. The reason why this business becomes complicated is because, this is one more, my mentor always said that electrons flow by the laws of physics, but electricity flows by the laws of politics. So, which means that when, there are things that we do in business that does not make any sense in physics, and I have a PhD in physics. So basically what happens is you have to meter everything, and you say this electron is going to go from here to here, and this electron is green and this electron is black, so we're going to tax that electron and not this electron. So how do you do that? So you have to put some meters up. You have to do, and they're all IEDs, So you can see now I'm building it up. So WAPA has over 500,000 IEDs, devices, various devices across our footprint. The key here is our footprint, 15 states. And that brings a lot of challenges for us. Just imagine our IT guy or our crew have to go to a remote site to do something, and the remote site happens to be somewhere out there in the boonies in Dakotas. And it's snowing. It's very, very bad scenario for most of the time for us. And the diversity that we have is, in one corner, we may be having a drought. In another corner, we were just dumped by snow. And that happens all the time. So we have to consider that when we are controlling our systems also. So another trivia question. When was the last time WAPA had an outage? Knock on wood, Never. That's the right answer. So the reason why is we take pride in what we do. We try to stay ahead of the game. We believe in one thing, and what we believe is anything that we set out to do in the agency, it starts from the leadership. The leadership has to believe in it. So I report to the administrator reports to Secretary Perry, and we sit in a room, and when we decide that, hey, protecting our critical assets is national security, then we set out a plan and we believe in it. And that's what happens in WAPA. I'm very proud to say that not one time in my 20-year career that I have been told that you're doing something wrong. Once we believe in it, we go do it. And nobody under me, hopefully, say that Subhash said it. They believe in it too. And that is the key to manage physical and cyber security. So here, we have so many ICS in our system, and I was talking to one of the gentlemen here. I said, we are a utility with a gentle overlay of US government. Of course, it was a sarcastic comment, but what it brings is a lot of exposure to us, because utilities are being exposed to a lot of cyber attacks, and being the government, it gets even worse. It's a double whammy, So WAPA.gov itself gives it away, And back in the day, I started my career when we did everything in RS-232. Serial ports was fantastic. It was great, awesome, But the problem with that was less data and less visibility on the system. Back then, it was okay. Now, things are changing. So how do you secure it? Of course, whatever Tom said is perfectly true. That's what we are doing today as well. But there are a lot of things that we are doing as well. Of course, the firewalls and the boundary protection devices. And we also have the fun of having devices from no such agencies. So they put those devices in our systems to monitor the data to see if any one of those packets match any of the signatures that we see as bad. So every senior executive in WAPA, we are 10 of us, and all the 10, we have top secret SCI clearances just for the sake of it, because we want to know, we want to stay ahead of the game, know what the source is so we can mitigate right away. And I think 2 years ago, I was in Houston. I was testifying in front of President Obama's panel where I emphasized on training and education. It is extremely important. There was one discussion that I had during lunchtime. Somebody was asking me, so if NERC or FERC levies more fines on utilities, you think they're going to go fix it? I said, that's a bad mentality. If you start levying more and more penalties on them because they did not do certain cybersecurity SIP requirements or whatever, all they're going to do is go fix that so they can be compliant. But that's not the thought process we should be having. It should be a risk-based methodology that we should use. What is your risk, and how are you going to mitigate that? So that is the most important thing about the training and education part here. So a year ago, we tied up with PNNL. Of course, Pacific Northwest National Labs is also DOE. So we tied up with them to do behavior analysis of our operators. Now, we have a control room. As a matter of fact, WAPA has 5 SCADA systems, and we have 5 control rooms across our 15-state footprint. So we wanted to know, how does our operators understand when a cyber event happens? Do they even know what to look for? A breaker trips, a line trip and reclose. We have a problem with an SF6 gas, transformer issues, piece of cake. They'll take care of it. They don't even look at it. We do N-1, N-2 scenarios. I can have almost a half a dozen 230 kV lines down in my system. Piece of cake. We can still take care of the system. We'll still be reliant 59.99 hertz, and we'll still be doing great. But we don't know how they react to a cyber event. So we simulated something, and we started asking them those questions to see how they react. And the rule number 1 we told them was, call your SCADA folks. Number 1, if you don't understand that number, because sitting in that chair for year after year after year after year, you know exactly in the middle of the night at 9 o'clock, PAT 66, it's the California-Oregon interchange, big pipeline, three 500 kV, and then a bundle of 500 kV lines on the other side. So it's a big pipeline. And we know exactly what's flowing from north to south. But if we see a discrepancy and it is very abnormal, call SCADA folks. Because it is very important to mitigate that right off the bat. It may be nothing, but those are the things that came out of training our folks. Very, very important to keep in mind. So I'm just going to play this. So, OK, there you go. So I'm not going to belabor on the technical terms and technical details of this, because I'm not that technical. Like I said, I sit in the C-suite. So, but legacy networks, usually you have the data plane and the control plane, right? The data plane is where the data traverses. The control plane basically tells you how the data should flow from point A to point B. But in a software-defined network, it's a completely different paradigm. Yes, you do have the control plane. Yes, you do have the data plane, but you also have an agent that sits on it that basically guides the planes, how to interact, how to work. And even better is that SDN controller, the logical control plane that sits on top of it, that does the things, gives those instructions to the agent, and once those instructions are there, then the data is controlled. I'll give you a perfect example. In the scenario of WAPA, just imagine we have I'm not going to name that place, but we have a place where you cannot get to the comm site. You cannot. The only way to get to is by a helicopter. And thank God we have a fleet of helicopters. So we send our IT guy up there. He flies up there. He hates it. But he gets up there and he takes care of things and comes back. And it breaks again, we go back. Costs us about $1,200 to $1,500 an hour to take that helicopter out there. It gets out of the normal things about what we are doing, like long lining. Our guys hang off of the helicopters to take care of the hot lines. They fix things when the line is hot. They do that, but that helicopter have to be diverted to do something else, an IT fix. In this scenario, just imagine where that SDN controller, that control plane is sitting in my control room, and Wilson here is our manager for the entire engineering staff in my maintenance. So Wilson goes, hey, I need to go. I have a problem with that. I have a spare 5505 RTAC. Can we put that online? Yeah, we can do that. We don't need a helicopter. We can do that right from the control room. That's one of the scenarios, real-time use scenarios. Not to mention it brings a lot of cybersecurity advancements to the network. Of course, again, here, in the legacy networks that we have, host A to host B, of course, when we say deny all, and then we add, we say, OK, here's one to this, and allow the ping. This one, don't allow the ping. But in a SDN network, imagination is your limit, right? I mean, you just have to think how to do the behavior of the system. I mean, you can categorize, say, these are my RTUs, these are my relays, these are my synchrophasers, and this is how they behave. And beyond that, they should not be behaving this way. When you put all that into this, the SDN switch, guess what? If you have a new device that you put online, and if it goes in that category, it's going to work. But if you say that this device is new, it has some characteristics that does not belong to the one that we define, it sandboxes it. And that is the beauty of it, because it happens right away with an alert to the user, so that we know exactly what's going on. And I'm looking forward to getting it done. So same thing about this. I mean, the auditing. I had this big conversation with one of my good friends here about tapping in a promiscuous mode to get some data off of a network switch. Guess what? I mean, like when you run VSS on your 6500s, you just lost one tap, and now you have only one tap, and now it is the data is coming in, your timestamps are different, and when you have CRC errors and things like that, they're not captured. There's a lot of limitation in that. There is no limitation here at all. Absolutely none, right? I mean, the data is captured, and it is put in the database. Another advantage is we have a problem, a relay tripped, and we don't know why. We fixed it, the line came back online, everything is good, everybody has lights on, and now we have to go back and recreate the whole scenario. We can pick that data that was in real time in our SDM in that database, and then put that in the lab. It happens right away because it's all in a connected system. Put that in there, run that scenario. The engineer can run that in the lab and figure out exactly what happened. Most of the times it is the mismatch between a relay between us and with PG&E or SMUD or Southern California Edison or Pacific Core or BPA, or it happens all the time. But it is good to know to have that replay. So what do SDN do? Of course, the most interesting thing for me is the ICS Cloud. I have that data, and data is very, very important to me. That's how I make decisions. That's how we analyze our system. It is extremely important to us to have that flexibility. Today we have tremendous engineering flexibility on our system. We have our ETS, our energy management system training simulators that our trainers train our operators all the time. The flexibility we don't have is on the network side. This brings that flexibility to our folks. We can bring data, port data from one segment to another segment, and immediately run that, simulate that, so our operators know exactly what to look for, or to figure out what exactly happened. And of course, your desired behaviors are defined in the software. I'm not going to read all that. I'm pretty sure everybody can read it. And this is another big one for us. It can also be used to transform our legacy data centers. Everybody has legacy data centers. WAPA has 2 geographically diverse data centers, and one sits in the Folsom, California area, and another one somewhere. I'm not going to name where that is. And we have our own network. We run our fiber on our top of our towers. The top of the tower is called the Goat Peak, and on that we have OPGW, which is overhead ground wire protection, and it is hollow, and we have fiber running through that. Every utility does that. We run, basically in my system in California, we run OC192. So we have tremendous data, but what we don't have is the flexibility in our network. So hopefully we'll get that, and we can get some flexibility in our data centers. So in the future, so we make our data centers more flexible and more robust. Use cases. Well, I just mentioned about the operations training, very, very important. An operator requires certain hours of training every year. Like clockwork, they have to do it every year, year after year after year. And then a security test bed. This is where our NSOC folks, our Network Security Operations Center folks, can sit. They can analyze. They can look at the data. Because believe it or not, if you're using SCADA, you use all the ports. All the ports are alive and cranking up. You go crazy when you look at the span data. What the heck is going on? First time you see it, you think somebody's hacked you. So this is how WAPA started phased implementation several years ago. As a matter of fact, I would say about 15 years ago, I was a project manager to secure our substations. And what we did was we called it the WIN network, WAPA, industrial network. And it was a hub and spoke, back in the day, whatever we had, we used it. No substation talks to each other. They all come back to the control room, and that's how we brought our data back. Very data intensive, and it is also very network intensive because the data has to come back to the aggregator that sits in the control room. So we went away. We came up with a new concept called Security Enclave Support Center. Some similarities, but very, very complex. Before we did this, we hired a guy from the dark side. He's our Chief Information Security Officer, Jim Ball, very close friend of mine, came from the counterintelligence of Department of Energy. So he knows a lot of that in the network and all that. So we all came together and we designed it, and it's operational today. The big thing about that is the correlation of data. For us, it is not just a cyber event that we have to go look at those packets. It's also what happened physically. The physical events. What happened with the camera at that time in that substation, all the way to the event that happened, what triggered everything. So we correlate all that. So we are working with the lab. Of course, it is a covert lab for Department of Energy, and we are working with them to come up with a device, a tool, which is so smart they have some proprietary software in there, which is so smart that it overlays all our GIS data of all our systems. In the background, it also has information like if there is an earthquake that just happened, and they pick up data from National Weather Service, and it pops up. If somebody has a Twitter feed in that area that says shots fired, or a 911 call or something, it just pops up right there. So it gives an alert to our physical security guys that, hey, something is happening. So number one is our employee safety. So if we had a trip, we usually send our crew, we call our Foreman 3. The Foreman 3 gets somebody and drives up there and manually looks at everything and talks to the operators. Very important. So this one will prevent us from sending those guys, because the number one thing is to keep the safeguard of our employees. So that helps us very, very much, but it also gives us a correlation of that event with any cyber event that has happened. So very important. It also allows WAPA one common approach. You know how difficult it is in the government to have one common approach across 4 different regions who operate like different utilities? Extremely hard. But I think we managed to crack that. We have one set of rules that we want to operate under, and we are moving in that direction. So, and that is the reason why I'm planning to, or it's already underway, to implement the software-defined networks in WAPA. Because if you look up WAPA and if you look up San Luis Transmission Project, that is something that I'm working with Duke American Transmission Corporation, DATC, one of the partners in that, with the water customers up there. We have a saying in California, we drink wine and we fight for water. So water is very important. So this line is for the water customers, and Duke is helping build it. Duke is helping fund it. but WAPA is going to build it. We have built several of those lines in Western United States. We have a lot of capacity and experience to do that. And it'll end up with 3 substations, and it is my vision to have all those 3 at 61850 compliant. We have implemented DCS probably 2 decades, or since 2 decades ago, we've been into DCS, and we've been maturing it. But the SDN coming into play will give us that flexibility that we never had before. In summary, ICS are moving towards newer networks, and some of our crew members, they don't even understand what TCP/IP is. So of course training is necessary, because we cannot get away and go back to RS-232. We can never go back to that, because with synchrophasers, there is tons and tons of data coming in, and we need flexibility on the network side, because we need that data, because I believe that the next step for the utility industries is not to react, but to proactively predict what's going to happen. And synchrophasers are going to give us that, at least a few milliseconds or at least a few seconds ahead of time that there is a fault and we know it. Because it can capture within three cycles, you can capture a fault, and if we know it, it's tremendous. To do that, of course, the crux of that is how you set your system up. I racked my brain for the 3rd bullet almost 20 minutes. So I'm very proud of that. So, and it's true too. With cyber threats ever increasing, it is important to have a network that can quickly adapt to the desired security posture to maintain business continuity. We are not a cybersecurity company. Our core mission is to serve our customers and serve the electricity reliably. But without cybersecurity, I think we won't do that. We cannot do what the Congress has asked us to do. So that's my presentation. Thank you.